what I wanted to do is just give you an overview of where we're going with the Internet of Things. There's a lot of view around Internet of Things. It's about the devices on the end and connecting to those devices, but it's actually a much broader conversation than that. And really, as we start to look at where IoT is going, it's actually more of a looking at how do you bring your data into your business, how do you collate that data, how do you triage that data, and then what do you do with it? And so when we think about where our products fit and the sort of conversations that we're having around IoT, these are the four sort of core pillars that we're focusing on. And I'm going to give you the 40,000 foot view, and then Sam's going to deep dive on some of the topics that I cover off. But what I want to do is start with a case study first. And this is a real case study, real business, Rolls-Royce. They make engines for multiple airline or aircraft types in the market. And one of the things that they used to do was they would hand over a whole heap of engineering resources to an airline, and they would say, here you go, here's all the software, go and monitor your own engines through engineering, and we can help you do replacement parts when things break, and and it's those delays at the airport that get created and frustrate us and frustrate the airline staff, and it actually adds a lot of cost to their business. So what Rolls-Royce wanted to do was build a business model around predictive maintenance on engines. Now, each engine has around about a terabyte of data coming off the engine every minute, off the sensors. So basically what they needed to be able to do is they needed to be able to wash through that data in real time, and they needed to be able to take the information off of that and then start to create some predictions around when particular parts of the aircraft or parts of the aircraft engine would need to be replaced. This is extremely complex engineering, and they really needed to run this model across multiple airlines to understand that. So our data science team out of Redmond got engaged with them, and we helped them build a model which is now they've commercialized as a managed service. So there's a number of airlines that are actually using Rolls-Royce's managed service, and all of the data flows through to Azure. Now obviously there's issues around how do you collect that data when the plane's in the sky? So, they're still developing how they do that, but essentially they do a dump of the software analytics that comes off the back of the aircraft when it comes into the airport, and then they're actually able to then do some analysis before the plane goes back out. So it's a really, really nice use case, and they literally use all of the stack. They go all the way from using our analytics products all the way up to using Power BI to actually provide that visualization to their customers. So when we look at the four pillars that we were talking about before, information management, event hubs for us is the ability to work out where all of the data is in the world, whether that's coming from a device and it's coming through some sort of protocol conversion. We talk about industrial automation a lot, and the industrial automation, there's half a dozen major protocols in the market plus lots of sub protocols. We actually have to get that into a common format that we can go and process. So we use event hubs as part of that process. Now, when we look at how we're going to analyze the data, it's not a single product that we would recommend to you. In fact, if you talk to our IoT team, they're probably going to go to the open source products before they go to our first party products in some industries, because it's standard. Like Apache, Spark and Storm are the standard product for a lot of customers today, and there's blueprint architectures available that just assist you to ramp in really quickly, particularly around collecting data off of sensors or collecting data in real time. As an example, one of the gas companies here in Australia, gas and oil companies here in Australia, they have around about 3,500 oil heads around the country where they're pulling gas and oil out of the ground. They would look to use Apache Spark and Storm because it's just evolved in that industry over a period of time. We also do have Stream Analytics though, which is a Microsoft product that we built, and we've got customers using it like ThyssenKrupp, who are an elevator manufacturer, and they've built a managed service around predictive maintenance on elevators as well. They have a global monitoring center, and they can look at every elevator that's under management from a single knock now out of the US, and they've got the ability to go and manage that. When we get to Data Factory, then that's also where we then go and manage the data and where it lives. So it could be sitting in NoSQL, it could be sitting in SQL Data Warehouse. We may be pushing that off to a third-party ISV solution, so we use that product to do that. From a data stores perspective, there's a number of options. We obviously have SQL Server, our bread and butter. We have our new service called Azure Data Lake, and I'll cover this off quickly. It's not available in Australia yet, but it's essentially a large-scale engine to to host and manage your data sets, and we can provide enormous performance characteristics through that platform. We have HD Insight, which is open source, industry standard. We integrate that both with Azure Data Lake as well as traditionals. And we also have partnerships with Cloudera and Hortonworks in the market, which are probably the two, and MapR as well. But Hortonworks and Cloudera are probably the two most commonly adopted Hadoop products in the market, and they can provide those services on top of Azure, and we've got blueprint architecture so you can quickly scale in to do that, including images in our Azure Marketplace. And then across to SQL Data Warehouse, which we've got a lot of customers doing SQL DW now, and moving things from on-premise SQL and moving them into Azure so they can just use the scale-out engine that we've got and some of the memory scalability that we've got. So from a machine learning perspective, we've got AML, which is essentially a product that what we're saying is we're democratizing machine learning for the non-data scientist. So it gives you the ability to visualize your models, make iterations to those models, and test those models in a graphical sense. And then you can go and publish those models. We have Spark and Storm, obviously we've covered off, and then we've got a Stream Analytics. And Sam will cover off some of what we're doing around the R analytics as well, and predictive analytics. And then from a visualization perspective, Power BI, which I covered off earlier, but we've also got the ability to go and publish the data out into Azure websites if you wanted to do that. Again, just leveraging a PaaS service instead of having to go and build, compute and manage the application platforms. But Office 365 and the ability to bring data into Office 365 is the most powerful thing out of all of this. So no matter what the data source is in the back end around IoT, if you want to bring it into Excel and do a complex model in Excel before you go and publish it, you can do that. You can bring it into SharePoint. You can bring it into a PowerPoint slideshow and actually have the visualizations change on the fly as you walk into the board meeting, so you get the most current, up-to-date, versions of that data. So, from an IoT perspective, it's an end-to-end game for us. It's actually it's more of a data game than it is a device game, and that's really where we're targeting into.